Hello, and A-level maths vectors, further maths, A-level further maths, and vectors question. Standard question on vectors, where you need to find the shortest distance between a generic point and the plane. There's some procedural skills here which are required for this standard question, and so let's do the math. The plane has equation minus 2x plus y plus z equals 5. The point P has coordinates 1, 0, 3. A, find the shortest distance between P and the plane. It also says the point Q is the reflection of the point P in the plane. Find the coordinates of the point Q. Now, I've just put into GeoGebra here. You can actually put it into your Casio CG50 as well. That's another short little lesson that I'll do to show you how that can be done. But this is just put in GeoGebra, so they just get a visualization as to the plane and the point P. So, and then I'm going to put in the reflection afterwards. So let's get going. So the first thing that you need to do is to use, let's have a look at this, okay, is use, oops, that's a bit too thick. It's all real time again. So let's get going. So is to use the formula. The book has perhaps not a nice adaptation of the formula. I prefer to use this one, which is x dot n minus d all over the modulus of n. Yeah, I prefer to use that. And then what you find is that you can write out what your values of n is, which is the coefficients of your equation, which is here, minus 2, 1, and 1. So n is equal to minus 2, 1, and 1. Now, distance d is, it says that's all equal to 5. So that means then that d is equal to 5, because it tells you that this equation of the plane is equal to 5. And the point which we call x is equal to 1, 0, and 3. Well, here's the point P has coordinates 1, 0, and 3. So that means x is equal to 1, 0, and 3. And I put it in vector form. Now, your distance can be calculated using, of course, the modulus of x times n and minus d. So that's what we're going to do. We're just going to substitute all the values in. And so that's 1 times minus 2. 1 times minus 2, this is x, and this is n. And it says x dot n, so 1 times negative 2, plus 0 times 1, 0 times 1, and plus 3 times 1, 3 times 1, and take away 5, minus d. And that's all over the modulus of n, which is, here we go, which is going to be minus 2 all squared plus 1 squared, well, I'll put it in brackets, plus 1 squared plus another 1 all squared. And, well, we've got to move that at the top. Whoops. Let's move this. And so we have access to, okay, good. So that will give you, when you go to your calculators and you put that all in, that will give you 4 root 6. That will give you 4 over the root of 6. And of course, that will give you, if you rationalize the denominator, that will give you 2 root 6 over 3. So that's part A done. So your distance then is 2 root 6 over 3. Now for part B, where it says find the coordinates of point Q, well, we know that the line segment along the shortest distance from P to the plane is the normal to the plane. And its distance is what we just found, which is 2 root 6 over 3. Now, I'm going to use R is equal to A plus lambda B. So if I use, going back to our first lesson really, use R is equal to A plus lambda B, and I extend the page, and R will be equal to, well, our position vector here will be 1, 0, and 3, which is the point P. So our position vector is 1, 0, and 3. And then I'm going to add lambda, and B, our directional vector, will be minus 2, 1, and 1, which are the coefficients of our equation of the plane. So minus 2, 1, and 1. And of course, I'm going to now deal with that. So that will give me 1 minus 2 lambda. So 1 plus minus 2 times lambda gives me 1 minus 2 lambda. And 0 plus lambda times 1, that will just give me lambda. And 3 plus 1 times lambda, that will give me just 3 plus lambda. So 3 plus, whoops, that's a plus lambda. So, better write that nicely. So there we have it there. 3 plus lambda. And here we go. Now, I'm going to take that and now multiply it by minus 2, 1, and 1, which is our directional vector given back, there you go, which is now the plane. That's the equation, the coefficients of the equation of the plane. So let's do that. 1 minus 2 lambda, lambda, and 3 plus lambda, and multiply that by minus 2, 1, and 1, minus 2, 1, and 1, and of course that's all equal to 5, because that's what it says. So now we have to multiply out, and I get minus 2 times 1 minus 2 lambda. Well, I better write it out so that you know what I'm doing. 1 minus 2 lambda, and then of course plus 1 times lambda, plus lambda, and then plus 1 times 3 plus lambda, and 3 plus lambda, and that's all equal to 5. Well, that gives me minus 2 plus 4 lambda, plus lambda, plus 3 plus lambda is equal to 5, and that gives me, well, that gives me 6 lambda is equal to 4. So that gives me 6 lambda is equal to 4. So lambda is equal to 2/3. So we're getting there. So we've got lambda is equal to 2/3. Now I'm going to substitute that back into R is equal to A plus lambda B. R is equal to A, using R is equal to A plus lambda B, and substitute the value of lambda in, but I've got to be careful because R is equal to A plus lambda B, where R is equal to A, which is 1, 0, and 3, because that's our point, going back to the question, of course, that's our point P. It says the point Q is a fraction of the point P in the plane. Find the coordinates of the point P. Now, if the point Q is a reflection of the point P in the plane, then the point Q is going to be somewhere equidistant on the other side. And here we go. Oops, it doesn't look like a Q. Yeah. So here we go. Here's our point Q. So, and that's a reflection, probably not accurately done, but that's the idea. But it's going to be equidistant. So if we call the distance from P to the z-axis m, P to m is going to be the same distance as m to q. So the distance from P to q is going to be double lambda. So we've got to multiply lambda by 2. So we've got the point P, which is our stationary point or fixed point, plus lambda, which is 2 lots of 2/3. Well, that's going to be 4/3, and then times by the scalar quantity, which is your coefficients of your equation of the plane, because that's your directional vector now, which is -2, 1, and 1. And there you have it. And that will give you the coordinates. And the coordinates will end up with, when you go to your calculator, you're going to find that that will give you the correct coordinates, which are -5/3. So the coordinates will give you -5/3. Therefore, Q will give you -5/3, 4/3, and 13/3. And that's it for 8 marks.